较不一样的分享，就是我决定挑战自己把 talk 用英文方式去呈现。原因是因为呢，我觉得说，我们已经有这个很好的活动，对不对？大家都会被聚集过来。那很可惜是说，随着我们这个产业继续发展，会有越来越多国际人才过来，但是他们其实听不太懂这边到底在交流分享什么东西。所以我决定呢，我的意思说，其实大家身为工程师都就是平常工作、日常工作都已经在接触英文，所以我相信其实大家都敢用英文去表达你的想法，只是我们不敢而已。那我今天就开一个先例，我用我的破英文来开这条路哈。Okay, so today I'm going to share a topic which is about the experience while I'm building our product, which is a system launcher. And while you are doing with the system launcher, you, to some degrees, because our product is about the overlay system launcher, that's why I'm going to share some different experience about this that will be so different from all the documents that you can find out on the internet. First, we gotta tackle 3 different subjects. First, what is the overlay? And then what is window? And what does it have to do the IPC? I'm not sure how many do you have any idea of what is IPC? Yeah, correct. Inter-process communication. Okay. So let's dive into overlay. First, I want to give you a small demonstration explaining visually about the overlay. Now you'll be seeing a screen which is the messenger bubble. Probably people use it every day, right? So this is the overlay. Overlay is just a concept from the user standpoint, which is something always on the screen. But in a mobile system, you always have one visual stuff to be focusable, right? And overlay doesn't necessarily to be always focusable, but it always shows on the screen. That is the overlay. And if I replay this video again, you will notice that I intentionally enabled the debug function show you the boundary of the overlay. So the focusable bubble, its boundary is actually changing while you are dragging it around. And then, essentially, overlay is a floating window in the Android system. To do that, you are required to have request special permission. And this special permission actually enables you to set specific type, window type. I know the class is super long and the name is super vague. That it's really hard to understand what is this type for window. What does it have to do with window, right? And we will talk about this later in our talk. In addition to the special permission, you also require to host your overlay under a special service. And the way to do that, this is an example. First, you gotta define this service in your Android manifest, right? And then somewhere, for example, like here, I use the start command callback, which is a callback that every time your application or the system launches your service, right? On create only calls get calls, for example, like once, but on start command, this callback can be called for many times for many reasons. But that's another subject. Right here, we just focus on the steps, the big steps. First, to have an overlay, you're gonna need a view, which is the traditional view people probably are already familiar with. And then you gotta configure the Windows parameters so that the system is able to know, how big is the window? What is the Z order of the window? Then you combine them together via the interface from the system Windows Manager, which is here. Is it clear that everyone can see my cursor? Okay, right here. All right, let's move on. And then let's talk about the host service, the hosting service. So, does anyone know that, does it have to do to launch the overlay within a service? Is it possible to do it in an activity? Does anyone want to make a guess? Hmm? Yeah. What about activity? Yeah. What if you launch this in your activity? Is it possible? First, is it possible? Okay. It is possible, but the problem is because the system has a parent-children hierarchy for the window as well. So if you instantiate the overlay window in an activity, once your activity goes away, that overlay goes away as well. That's why you need a service to host it. So in other words, that means you essentially need a hosting process, because in Android system, every application has its dedicated process, right? And within that process, activity is just a component occupying the resource, computing resource, including the CPU and memory, right? So as the service. So essentially, you just need a hosting service process. I can tell that you disagree, or you have a question to ask. Do you want to me now? Oh, yeah. Oh yeah, because window can mean different things in different area, right? Like when we're using the Windows system or the Mac system, window is essentially this rectangle that you can drag it around. But in Android, maybe it's similar, but probably can mean something different. And overlay is more close to your users. But I know in Android system, they somehow create another view, happen to have the same name, overlay. I'm not sure if that is your original concern. Anyway, yeah, I guess, okay, I'll use the window later on in our talk. So then we start to think about what is window, and then there will be 5 subjects, as it is described. A window is essentially a collection of view tree, like hierarchy, like view group. Inside a view group, there might be another view group, and so on and so forth, until at the bottom there's a view without the children. And then we have to talk about what is window type, and how does Android draw this roughly. And then what is WindowManager, and how did you use the ADB debug to help you get more understanding from the system. And then first, we take a look at a podcast app. This is the Google podcast app. And I assume that because we are all Android developers, we already know what is the view hierarchy look like. Essentially, it is a list of lists, right? A list vertically with a bunch of horizontal sublists, right? So we have a yellow parent, and then green, and then blue. And then because this is a application, so actually it is using something called activity window. I call it activity window. That means your activity actually create this window, and that class is what we call the phone window. And inside the phone window, there's a view parent called decor view. And what it does is actually, you can imagine that it decorates your content view, right? By adding the inset of the system bar, adding the inset for the system bar. Otherwise, it will overlap things with the system UI and the navigation bar at the bottom. And then the smiling face view is the content view, which is the view you give it to the system inside the activity on create callback by calling the function set content view. And then here it is the primary goal that we are about to talk today, right? Floating window. So floating window is also a phone window, and inside the phone window it is another class called view root implementation import, and then your smiling view tree. so far, can you see the difference? All right. Okay, people are so tired. Yeah. So the difference of the activity window and the floating window is this. Where for normal application you need decor view to decorate your application, your content view. But for floating window you don't. Right? And the common thing of this guy is it handles the responsibility of the touch dispatch, rendering dispatch, measurement dispatch. Everything starts from here or here. I mean, roughly. Then, remember that we talked about the window type. And then here, this is a snippet of the window type. The window type is encoded as integer. And now, if you take a look, the base application, the value is 1. And then how does it become in 2000 right here? And then you can see, oh, the system alert is 2003. And then, oh, input method is 2011. Why is there so big gap out there? Because in the Android system design, window type is essentially the Z order of the window. And many years ago, somehow their engineer determines that, oh, we don't necessarily need maybe 2,000 windows on the screen. Even you have 2,000 windows on the screen, it will stack, overlap a lot, right? So they just have this buffer for populating the windows out there. And then from there, we gotta ask ourselves a question, simple question. Given a view tree, how does it draw inside the system? First, your root view will get a canvas, right? And then canvas is, my understanding is like canvas is a collection of drawing commands. What does that mean? That means, oh, someone wants to draw a line out there, right? And I create a drawing command. I add it to the canvas. So your root view, first, he's the first guy getting the canvas, and he knows what to draw or what not to draw. And then he gives the canvas to its children, so on and so forth, until it hits the button. And then it will goes back. Then someone else inside the system must be consuming this canvas, right? So here, from here, we actually got two questions. Who gives you the canvas? Who consumes the canvas? Right. We will know that later on. Here comes to our question. How Android draws roughly? For each horizontal line right here is like a representation of the process inside the Android system. And there's in general, we call it a system process. Maybe there are more, but we imagine there's only one. And this is your application, right? And there are a lot of other applications. Okay, so take a look at the smiling face. This is like an activity. At the beginning of the activity, let's say the instantiation process, your activity will ask the system process to have some boundary in between itself and the system so that it can get the canvas, all the necessary information to retrieve the canvas. And later on, once it goes through the drawing process, you know who to give it to draw. So it first has to give the system process a application token, which is the identity for your application, and then get the window session back. I mean, I oversimplify everything because underneath it's so complicated. If you have a chance to dive into it, there's so many classes with so many confusing names. And then here is the window manager. Oh, reminder, so as I mentioned before, each application has a dedicated process. I mean, here, by process mean the Linux process, or DelVix process. So each application actually has a window manager. That is just an interface. We call it a shim, like an interface. And it's instance is WindowManager import. Each application have that. And the system process handling this communication is actually this WindowManager service. But don't be misleading by the name. It is called manager service, but it is not a service. It is just I don't know how to code it. It's just like a collection of code. And somehow system launched that, and everything just being starts spinning off. We don't dive into that detail too much in this talk. And then we want to know how to debug this so that helping every of us to understand how does the Android system work. For example, like take a look at the screenshot on the right side. This is a search bar along with the keyboard, right? As we know that, if you look at the line 1, the window is actually a input method window, right? So everything on your system is a window. And if you scroll down, you can see, there's another Nexus window, whatever. Anyway, for example, here's an interesting case. In most of the use case, when your software keyboard pops up, you will notice that the size, the height of your application is smaller, right? Shrinks. Because the system handles this magic for you. When this special window pops up, the system process know, you gotta change the size of the client. We call whatever right there is the client. That essentially leads us a problem, which is the inter-process communication. And so on and so forth. You will see the iBinder right here. Let's take a look of this picture again, right? We talk about what is the app token, the app identity. That guy is actually an instance of iBinder. And iBinder is a special class that you will have the same virtual memory address